talk about that intermediate value theorem. Okay, first of all, let's remember that what is a root? A root is an x-intercept. Some of us forgot that when we were filling this worksheet. Okay, so in number 2. No, I'm just reading it. Which of the following must happen between 1 and 5? Number 2. What has to happen? Why? It has to cross the x-axis to get from that first point to the second point. It has to go through the x-axis, which means there's going to be a root. The third question, which of the following values must it hit? -1 and 2, says Zach.
Wait, I think it says which of the following heights.
Heights?
Yeah.
Okay.
Wait, wouldn't 5 be?
Would you care to elaborate, Luke? Nathan. Sorry.
Wow.
Nathan, would you care to elaborate?
Wow.
Just say no to anything. Say no.
We don't not anymore.
Yeah, so call Ruth then.
You need to call him up.
Zach, would you care to elaborate?
He's like, yep, that's right.
There it is.
Because with the continuity between them, it has to pass through all of the y values between 3 and -4, and -2 and -1 and 2 are the only y values on that list that are doing it.
Okay, no matter how you draw a continuous function, whether you drew, I guess I could write up here, whether you connected those with a line, whether you connected them like this, okay, no matter what, you are going to have y values between
-4 and 3.
-4 and 3.
Yeah, Brady.
Okay? That is the intermediate value theorem. We have 2 points, and if it's continuous between the two, you got to go through all those y values
Then why
to
won't
get
they
there.
just say that instead of making up all this like
Mumbo jumbo.
gibberish stuff and
I wanted you to come to that conclusion. I wanted you to say it in your own words without me having to write it up here.
Well,
Okay.
there was
There was.
Okay? So the intermediate value theorem. Okay? How many of you looked it up in your book to write it down on there? That's fine. Okay? If f is continuous, it hasn't been working lately. It's very disappointing.
You should try to unplug and plug it back in.
You just want to see. Cop. Okay. So if f is continuous from A to B, where those function values differ, then between A and B, okay, or f of A and f of B, there is at least one number C in the interval where f of C is K. And where does that K have to be?
Yeah, like K has to be somewhere.
Okay, K has to be between f of A and f of B. Okay? So let's just put it in our own words. Okay? We have 2 points and there's continuity between them.
There has to be another point between them.
There's going to be a point between them, first of all, and that function value can be somewhere in between. Right? Okay, so let's look at Nathan. Let's look at that problem. 87 that I accidentally assigned.
I was representing
F of x equals 1/12 x to the 4th minus x cubed plus 4 on the interval from 1 to 2. Explain why the function has a 0 in the interval.
What number is it?
This is 87.
Isn't it one?
What?
Isn't it one
That's
over
when you
12?
Well,
One over 12?
Aw. Is that? Well, okay. So help me out. What's f of 1?
37.
And what is f of 2?
Negative 8/3.
Thank you. Is this going to cross the x-axis between 1 and 2?
Absolutely.
Why?
Because it's a negative and positive.
Okay. So first of all, our defense would be the intermediate value theorem, right?
Yeah.
We start at a height of 37/12. We end at a height of negative 8/3. So somewhere between 1 and 2, we're going to have a height of 0.
Wow, that's pretty easy stuff.
Isn't it?
That's honestly a really way easier
That-
than it was.
Yeah.
Yeah.
So
But
if those numbers are higher than the,
It's gonna.
So as long as one's negative and one's positive, it has to do 0.
right, as long as one of your function values is above the x-axis and one is below, it's going to have to pass through the x-axis. Now, and that can be applied to, you know, if one has a function value of 1 and a function value of 5, you know that somewhere in between there, you're going to have an f of c of 4, or equals 4.
Wait, is that saying like between like 1 and 2? I mean, on the x-axis, on the 2 points between 1 and 2, it's going to cross the x-axis. Alright.
Exactly. Yes. Okay. Not so bad, right?
Yeah.
Okay. After talking about that, does that worksheet just all come together?
Except for number 7, the real example.
Real life example.
Throwing a baseball over a foul line.
Okay, what?
Throwing a baseball over a foul line.
Over a foul line?
A foul line, okay.
the white chalk? I don't know why someone would.
Oh, okay.
There's a battle over 32 buttons, you couldn't scoop it.
Okay, yes.
Mine was if a ruler stretches from 0 inches to 12 inches and is continuous in between them, there must be like other numbers.
Okay. Great. Great. What about we have a swimmer.
Two.
We have 2 swimmers. This is true.
I swim in the summer too.
Okay. So let's diving board. Right? How high is the dive?
Pretty low.
What?
12.
Pretty low. 12?
We'll say 12 feet. If you jump off the high dive of 12 feet and land in the we'll say water level 0. At some point, you're going to be 2 feet above the water.
I mean,
That's fair.
Like on the way down, right?
Water level.
Like, no, I'm saying that,
like underneath, like in the water, it's like,
It's like
Yes.
The water is at 0.
there's 0 water.
there's no water in it.
let's talk about infinite limits, okay?
Yeah.
Now, before I told you that if we had unbounded behavior, then we said the limit does not exist. That is still true. However, we can now describe unbounded behavior. Okay? So I want you to understand that these limits still do not exist, but we have a way of describing how they do not exist.
Describing their non-existence.
I'm so,
Okay.
yeah, I'm trying to figure this out, and you just throw words in there, I'm like, what?
Okay, so here
This video is gonna be good.
we have, you have anything else, Lori?
Doesn't mean.
Okay, so here we have the graph 3 over x minus 2. What is happening at x is 2? There's an asymptote. So you know that if we talk about the limit as x approaches 2, it doesn't exist because it's unbounded, right? Okay, well, if we look at the limit as x approaches 2 from the right, it is unbounded in what direction? The positive direction. So we're going to describe that limit as positive infinity. It still doesn't exist, but we can say, hey, we're unbounded to positive infinity. Okay? The limit as x approaches 2 from the left of this function, on the left of our asymptote, we're going towards negative infinity.
So that was like a flip, you just flip positive.
What?
Yeah, you kind of this. I'm like, what are you saying?
No, I don't.
Say that again?
I don't know. I don't
Well,
understand.
it's like, if that curve is up there and this curve is down here,
Then those are two.
yeah.
Yes, then those two would flip. Okay. Now, what are we going to have to understand about graphs in order to describe their unbounded behaviors? Okay, we're going to have to first of all figure out where those vertical asymptotes are, and we're going to have to figure out what's going on either side of them. Okay, so that's what we need to focus on. So first of all, let's take some functions and think about vertical asymptotes. Okay, vertical asymptotes, they are what kind of discontinuity? Non-removable discontinuity, don't forget that. Okay, so let's identify these asymptotes. H of x, Jimmy, where is our asymptote? Yes, thank you. Okay, at x equals 1, we have an asymptote. Do you agree with Jimmy?
Yes.
Excellent. F of x. Which, yes, is really j of x. What should we probably, okay, what did you say? 2?
X equals 2.
Okay.
Correct.
And
There's a
negative
hole
2?
No.
There's a hole. There's a hole at 2 and
Because
then X
once you
equals
simplify it out, you get
Okay. So let's simplify. Let's factor to see if we can simplify. What's happening at x is 2? There is a hole, so where's our vertical asymptote? Can we find the limit as x approaches 2?
Yes.
Yes, there's a hole, so it's going to exist. Okay. What?
Yes.
Okay. G of x. Okay, so first of all, does secant of x have vertical asymptotes?
No.
Sure,
Yes.
so-
It does.
Yes.
I'm
saying yes, because
Let's rewrite this as 1 over the cosine of x. Does the secant have asymptotes? Yes, every time cosine is 0. Where is the cosine 0? Pi over 2 and 3 pi over 2 and 5 pi over 2 and over and over and over.
2 and 9.
How did you
How
get
does that, cosine doesn't, oh, because equals 0.
What are you feeling?
So pi over 2 is where we have an asymptote, and then it happens every pi. Right? Okay. So now, are you ready?
Yeah.
You are ready.
I'm ready.
I'm not ready, go ahead.
Okay. So we're going to look at the left and right hand limit as x approaches 1. Okay, so first of all, what is happening at x is 1? Okay. So we want to find the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. Okay, so this is what you need to do. We know that since there's an asymptote at x equals 1, we're going to have unbounded behavior. What we have to figure out, are we increasing towards infinity or are we decreasing towards negative infinity? Okay, so let's look at the left side here. How might we figure out if we are increasing towards infinity or decreasing to negative infinity? Okay, so let's look at a number like super duper 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 close to 1. but on the left side.
0.9.
I would say like 0.9. If we plug in 0.9, are we going to get a positive or negative number? Positive number, right? So we're going towards positive infinity. You could even try like, okay, so 0.9, you could even think about like 0.99. It's still going to, anything to the left of 1 is going to make this a negative number, and you'll have negative divided by negative to be positive, right? Okay. Let's think about this. To the right of 1, anything that we plug in here would create this fraction to be negative. And so we're going to be decreasing towards negative infinity. Okay? We have to think about what's happening with the graph in our head. Okay? Okay? Okay, let's look at g of x. What is happening at x, or x equals 1? There's an asymptote. So we're going to look at the right-hand limit and the left-hand limit. We know that it doesn't exist, so we can describe it as positive or negative infinity. Okay? So, what? What do you mean factor in? Okay. So, well, direct substitution wouldn't be so awesome because we'd have 1 divided by 0, right? But we have 1 divided by 0 in the positive or negative direction. If we plug in numbers just to the left of 1, what kind of numbers are we going to get here? Positive. So we're going towards, would they both be positive?
Yes.
That's an interesting discussion that we can have now. Okay, good. So we know? Yeah, it looks like this, right?
Well, if you plug in numbers further away from 1 that goes to 1, you can get -2. If you,
Those are never going to be negative because you have 1 over something squared.
oh, so you do
Right, right. Okay, so now, what if I ask you for the limit as x approaches 1?
And it doesn't exist.
But can we describe it? Okay, from the right and the left, our limit is positive infinity. So if we say the limit as x approaches 1, it would be positive infinity. Now what about over here if I ask you for the limit as x approaches 1? This does not exist in a way that we could describe. Okay? All of these limits don't exist, but we can describe them with infinities and negative infinities. Okay? Now, make sure when you're going through these problems, identify whether you have an asymptote there or not. Because if there's not an asymptote, what could you probably do?
Find it.
Direct substitution, okay, or use some algebra and then direct substitution, okay? Think about this one.
0.
Okay, so we have the limit as x approaches 0 from the right of 2 over sine of x. Okay, so if we use direct substitution, what's happening? 2 over 0. And we're getting a 0 in the denominator because what's happening there? We have an asymptote. We cannot rewrite this function to make that 0 in the denominator go away. So let's think. What did you say? And why would it be positive infinity, John?
Because if you put a positive or a number bigger than 0 on the right side for x, then it's going to be 2 over a positive number.
Okay, if we look at numbers just barely to the right of 0, those sign values would be positive. So we are going to go towards positive infinity.
So you don't have to show anyone what that means, right?
I love this. Way easier than yesterday. You don't know.
Okay, now I would not write these down. Okay, let's talk about these. Okay, first of all, these are in your book, so you can reference them if you need to. I would not waste the time writing them down. Let's talk about them. Because to you, you're probably like, oh yeah, well, I would assume that anyway. Okay? If we have limits of f and g that are both, well, okay, so the limit towards c of f is infinity, and at g it exists. So when we add those two limits, there's going to be infinity, because you're taking infinity plus more, still infinity. If you multiply those two limits together, it's going to be infinity. Depending on,
What else?
right. If L is negative, then it would be negative infinity. Okay? If we divide, if we take a value divided by infinity, then it is 0. Because let's think about that. You're taking a number divided by something that just keeps getting bigger and bigger and bigger, 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 bigger. 0. How does everyone feel about that?
Very, very good.
What if it was infinity divided by 8? Divided by f?
Then it would be infinity.
Come on. 8 months does. 3 months.
Okay, so what if it's, so the first one, what if it's like
High end.
positive infinity minus, or plus negative infinity? That would be 0.
Well,
Shiny light.
that is what we call indeterminate.
Alright, let's not get into it.
And that is something that we'll get into only a little bit in this class, but then a lot more if, well, if you take
Yeah, alright.
Calc 2. There's more.
Last example. Okay, so look at the graphs.
The Mexican.
Okay. I want the limit as x approaches -1 from the left of f of x divided by g of x. So what is the limit as x approaches -1 from the left of f of x? Right there, right? -1. What about of g?
Uh-oh.
Okay, now since we're taking since we're taking a one-sided limit, we can describe this. Okay, so can we describe this as infinity or negative infinity? Why negative infinity? Okay. Okay, what's important is how we're approaching the 0.
Wouldn't it be
Right.
positive?
Keep going, John.
Because if you plug in a number for the g of x on the left side of 0, it goes down to negative.
Okay, so we're approaching 0 from the negative side, right? Which means these values right here, as we're getting close to 0, are negative numbers, right? I know there's no such thing as a negative 0, but we're talking about a limit. As we are approaching 0, we are doing so with negative values. So we would describe this as positive infinity. That's very
Why is
good.
that? Because all of these are dividing.
So like if you plug in negative 2, you'd be
Well, like just look at what's happening. As we're approaching -1, we're doing so with negative values.
So what makes it positive?
Negative divided by a negative
Oh,
is
so we're
positive.
looking at it as a whole?
Yes.
So
Yes. Okay. So,
Now what?
the limit as x approaches -1 from the right side of the quotient. Okay, so this is still -1 over 0. Okay, but these numbers are positive numbers as we approach 0. So negative infinity. Figured it out?
Yeah, well, I mean, yeah.
Ask
No, I understand this, so this doesn't bring the question.
that you would like to ask or no?
No.
Okay.
I'm good. I'd confuse myself.
You have a 3-day weekend.
Oh, baby.
Okay, you have 3 problems about the intermediate value theorem, and you have a bunch of limits. How many of these limits required work? Like none of them. Okay? It's all up here.
Spanish, not Mexican.
Who said Mexican?
Carter's like, let's speak Mexican.